Okay, now we're going to go over EMG. So this is testing the electrical activity of the muscles. So taking it back to motor control, if you've taken that class already, or maybe you're in it right now, this is the most basic understanding of motor control. So we have an action potential that's in the brain, so that's our brain telling us that we want to move something. That action potential, which is an electrical activity, that travels down the axon all the way to the neuromuscular junction of the muscle that you want to move. So this is where it comes in contact with the muscle fibers to tell them to contract. And then the muscle fibers do just that. And using that electrical activity sent from the brain, the muscle fibers shorten to carry out that contraction. So, understanding that very basic concept, or at its most basic level, we can understand why we might use EMG and why EMG works. So surface electromyography is non-invasive. So there is EMG measures that actually use like a probe that's inserted into the muscle belly. That's a much better measure of muscle contraction, but as you can probably understand, is very invasive, not that fun, and not something we're doing in this lab. So instead, an alternative is surface EMG, where we just use these little electrodes that get placed on the muscle belly and pick up electrical activity. So we have that electrical activity traveling from the brain to the muscle belly, telling it to contract. And when it does contract, it's using that electrical activity to do so. And we pick up on that with these surface EMGs. The electrodes are placed on the muscle of interest, and then you can visualize the electrical activity. So you can see this is a tricep EMG. So you can see the contraction of the tricep here, relaxation, contraction. So someone was probably just doing reps of something that engaged their tricep. So we are able to visualize the contraction and relaxation cycles of the muscles using the surface EMG. Now, you can probably guess that this is great for usability and acceptability by patients, but might not be great for understanding deep muscle contraction because we have to use it on the surface, or muscles in like, say, the back where there's a lot of different small muscles kind of crossing over and overlapping each other, where it might be hard to target the specific muscle. But for big muscle groups like the glutes, the quads, calf muscles, this is a really great measure of EMG, or that electrical activity. So there's a lot of different uses for EMG, but some basic ones would be like in rehab, physical rehabilitation, or gait and posture analysis. You can get a good glimpse of how someone's muscles are contracting and what pattern they're following, which can be helpful for rehabbing an injury. So say you have an individual that is engaging their back when they should be using their glutes and they have glute weakness. You can show them visually with an EMG how their back is contracting and help them target that glute contraction instead during a given exercise. It can also be used in ergonomics, so with risk prevention or analyzing the demand of a certain task. So what's the demand of the like shoulder muscles during desk work while someone's standing all day or sitting all day? What muscles are contracting? What would be better posture? You can analyze this kind of what muscles are being used most prominently, and revise that and guide people to change their posture and behaviors to be more ergonomic. It can also be used in training. So if you have an athlete, you can use this in biomechanical analysis. So are the correct muscles contracting at the correct times? This can be applied in strength training as well, where you're targeting muscle activation and making sure that form is proper and that they're not putting themselves at risk by using muscles that shouldn't be used during a given exercise. So there's a lot of different outcomes you can get from EMG, including activation patterns. So how long after the bicep contraction does the tricep antagonist muscle contract? Just as one example. You can look at fatigue. So you would expect the electrical activity of the muscle to change as it gets fatigued. So more muscle fibers are likely recruited to carry out an exercise when you're starting to get fatigued. So you might see changes in the volume of contraction. You can look at burst rate and peak muscle contraction as well. So how rapid is the contraction happening, and then what is the peak millivolts or volts related to that muscle contraction. So you can use it for a whole host of things. Risk prevention, training, all of these can be applied using the EMG by detecting that electrical activity of the muscle contraction.